Can you hear me now? Hello? Yeah, so I was saying it is not a problem because I'm going to teach from very basics. So we are going to start with random variables and the classical probability which you're talking about, that I'm also going to explain in the process. So random variables is a completely different stream here. So it is not going to be a problem even if you do not know what is probability, because we are going to define it. We are going to define it in great detail here. Okay. Okay. So I'll wait a bit before other people join. So for now, let's address your issue. Can you tell me how much of probability do you know? Like, do you know the basics? Okay. Hi, introvert. Okay. So let's start with the basics. You've known the basics. Great. So now, what is a random variable? A random variable, call it X. As the name suggests, it is a variable and it can take on values. Let us say there is a random variable which takes on three values, 0, 1, and 2. Okay. Now, why is it called a random variable? Because this variable can take on values, but it does not take on them definitely. Like it takes on them with some probability. So the definition of random variables is made such that we have x equals to 0, comma 1, comma 2, and we can do it like this. What we can do is we can assign probabilities to each of its outcomes. So when x is 0, we can have some probability p1. When x is 1, we can have some probability p2, and when x is 2, we can have some probability p3. And we are assuming that these are all the outcomes that x can have. So probability of x equals to 0 is p1, x equals to 1 is p2, and x equals to 2 is p3. Okay. Now, since these are all the outcomes you have, and you have known in normal probability theory that sum of all probabilities must be 1 of a particular event. In this case, all of this also constitute the sample space. So this is called what? The sample space of x. Okay. So basically, we must have P1 plus P2 plus P3 equals to 1. This must also be satisfied. So a random variable is such a variable which can take on values, integer values, or maybe fractional values, but they have to be discrete in general, because we are right now talking about discrete distributions. We'll also talk about other distributions as well, but we are starting off with the very basics. So let's say x is a variable, such a variable which takes on three values, 0, 1, and 2. And the probability that x is 0 is p1, probability that x is 1 is p2, and the probability that x is 2 is p3. These are the three different probabilities that we have. We must have, if this is the case, we must have p1 plus p2 plus p3, that is the sum of all these probabilities, as 1. Also, we must have 0 less than equals to p1 or p2 or p3 less than equals to 1. So these are the two conditions that must be satisfied in order for us to have a variable which can be successfully called a random variable. So this is how a random variable works. Okay. Now, what is the binomial distribution and why do we even consider it as a probabilistic distribution? Is what we are going to learn today. And what are the uses of it? Why do we use the binomial distribution and how to apply it to such a certain scenarios in different problems or even in real life, right? So the binomial distribution, let me just give a heading here. So let's say this, we have the binomial distribution, right? Now, what is the binomial distribution? Binomial distribution can be defined if you have a random variable x. This x follows a certain distribution which we generally write like this b, and the binomial distribution is said to have two parameters n and p, where n is called the number of trials and p is called the probability of success. Success. Okay. Hi, Padmini. So for binomial distribution requires events to be exhaustive. So do you mean that, like, when you are saying events, I'm assuming you are talking about the events that occur under X. Like, let's say we have X as X is distributed as binomial. That is how we are going to read this sentence, this particular sentence here. X is distributed as binomial with parameters n and p. This would basically mean that the values that X can take are from 0, 1, 2, and all the way up to n. X can take all the integer values from 0 to n. And now it can take this n plus 1 values, that is true. But there is one more thing. There are different probabilities associated with each of these numbers, which X can take. So yeah, they cannot occur simultaneously, first of all. That is true. Also, the probability is defined as follows. For any x equals to k, where k is any number from 0 to n. Okay, you can take any number from 0 to n. We are going to generalize it. For any value k, which is between 0 to n, probability that the random variable x takes the value k is given as n choose k multiplied by the probability of success for that particular binomial distribution, which is p. So we can simply write p to the power k and 1 minus p whole to the power n minus k. We can define that. And some textbooks also might define it as p to the power n minus k whole into 1 minus p whole to the power k. So whichever way you can define it, it does not really matter. But this is what basically you have. This is the general formula. Okay, you can also define it like this. I will give an alternative sign here. N choose k, p to the power n minus k, 1 minus p whole to the power k. And you basically have summation k equals to 0 to n, probability that x equals to k is equals to 1. This must be satisfied, right? Because it's a distribution. So sum of all the probabilities must be 1. What I mean is this. If you call pk as the probability that x is equals to k, and you know that k takes on the values from 0 to n, all the integer values, then we must have that p0 plus p1 plus p2 all the way up to plus pn equals to 1. This must be satisfied. So the first thing we are going to do is we are going to try and figure out if this is at all satisfied or not. We need to prove this. We need to see if these probabilities actually add up to 1. And to do that, we must know the binomial theorem. So if you are not aware of the binomial theorem, this is a good place to learn it right now. So what is the binomial theorem? Okay. Now, the binomial theorem is simply given by this. You can say that for two numbers a and b, and if you have an integer exponent n, positive integer, I might add, we are not talking about negative integers or even fractional values, although even if you had to have like fractional values or negative integers, this binomial formula still works, but instead it gives an infinite series and not a finite series. Anyway, so for integer n and any two numbers a and b, they might be complex. It does not matter. The binomial theorem simply states that this is equals to k equals to 0 to n, the summation where summation goes from k equals to 0 to k equals to n. Inside we have n choose k multiplied by a to the power n minus k into b to the power k. This is simply the binomial theorem. So if you were to expand it, this would look something like this. N choose 0, a to the power n, b to the power 0, plus n choose 1, a to the power n minus 1, b to the power 1, plus n choose 2, a to the power n minus 2 into b square, and so on. So something like this is what we will have from the binomial theorem itself. Okay. Now, why is this useful? This is going to be useful because if you see here how the binomial distribution was defined, the probability that any that x takes the value k is defined as n choose k. Let's consider this one because this correlates with the binomial theorem. N choose k p to the power n minus k 1 minus p whole to the power k. This reminds you of the binomial theorem. And we need to prove that sum of all these probabilities must be 1 in order for this x to be a random variable and it to have binomial distribution, right? So we what we can do is we can again write here first that okay, we know that probability of x equals to k is given as n choose k multiplied by p to the power n minus k into 1 minus p whole to the power k. Correct? Now this is the probability of the random variable x having any value k. Now if we were to sum it over all possible values of k, okay, like k goes from 0 to n, right? So if we are going to sum it for all possible values like this, summation of k equals to 0 to n, probability of x equals to k, then this would mean we are basically summing this expression k equals to 0 to n choose k into p to the power n minus k into 1 minus p whole to the power k. Now, this is exactly the same. This is exactly the same as this binomial theorem which we just studied, right? Like this k equals to 0 to n and choose k to the power n minus k into b to the power k. This is the completely same thing. So obviously, if you were to do this, you would see that correlation here is a is basically p and b is basically 1 minus p. This would give us k equals to 0 to n choose k, and we are going to consider this as a and this is b. So this is a and this is b, and I might as well write it. Give me a second. Okay, so let's say this is a to the power n minus k, and this is b to the power k. And with this in hand, we can get this value as a plus b whole to the power n, which is nothing but p plus 1 minus p whole to the power n, which is 1 to the power n. And this would give you basically 1. So yeah, the sum of the probabilities is simply 1. Okay, so we proved that in the binomial theorem, we have the sum of the probabilities equal to 1 and that all the probabilities are basically non-negative. So yeah, that completes the task we have at hand right now. And yes, when x is then binomially distributed, we know what probabilities look like. So let's take an example here. Let's take an example. Let's say there is a fair coin, and it is tossed 10 times. Okay, it is tossed 10 times. So if a fair coin is tossed 10 times, what is the probability? So basically, we're trying to find out the probability that exactly 5 heads come up. So this is what we are trying to do. If a fair coin is tossed 10 times, what is the probability that exactly 5 heads come up? Now you have to understand, for a probability problem to be binomially distributed, there are some conditions that it needs to meet. So first of all, we are going to define the random variable x as number of heads in a single toss. and we're going to define this as, let's say, xi. Let's say in the ith toss. So we can rather do it like this. We can rather define number of heads as the sum of number of heads. Actually, that works better because otherwise it would be a Bernoulli distribution. So x is basically the number of heads. Okay, so if x is the number of heads, then what we can do here is this. We need to first see if the trials are independent. So the first condition you must check if the trials are independent. And the next condition you must have is this. The probability of success remains same. So the probability of success must remain same. So these are the two conditions you must have in order for a random variable to be binomially distributed. So you must check that the trials are independent. You must check if the probability of success remains same. So yeah, when you're tossing a coin, you can understand that tossing a coin once is the first trial. You're tossing it again, this is the second trial. And these two trials are independent. That is, the outcome of the second trial does not depend on the outcome of the first trial, and neither does it depend on any other trials. It is an event in itself which does not depend on anything else. That means the trials are independent. Also, the probability of success. Now, in a fair coin, the probability that you get a head is basically 1 by 2. Because it's a fair coin, that means heads and tails are equally likely to occur. So the probability that you get a heads is basically 1 by 2, which is our probability of success. And with this in hand, and we know that that coin has been tossed 10 times, we understand that this x is basically the number of heads is basically a binomial distribution with parameters. There are 10 trials, and the probability of success is half. And once we have reduced that, it is easier to get the answer. The question was basically what is the probability that exactly 5 heads come up. We know that x basically counts the number of heads. So what we can do here is this: probability that x is equals to 5 would be equals to, we just put in the value of the probability formula that we learned for probability of x. So 10 choose 5 into half to the power 10 minus 5 into half to the power 5. Notice that 1 minus half is also half, and this would simply give you 10 choose 5 into, and this would be 1 by 2 to the power 10, and that is going to be your answer. That is going to be your answer for the probability that exactly 5 heads turn up, right? So, okay, this was one of the examples. Now, any example where you have number of trials which are independent or number of, and the probability success remains same, so you can use this binomial theorem. Now, let's talk about something which is called as the mean or expectation or average. So this all mean the same thing in this binomial distribution scenario. In all the probability distributions, they mean the same. So mean, or you can call it as expected value, or you can call it the average. All these three terms will mean the same thing. So these are the same things. All of these are same things. Okay. And what is this? So if there is a random variable x which is following a binomial distribution with parameters n and p, we say that probability of x equals to k is how much? This is simply equals to n choose k into p to the power n minus k into 1 minus p whole to the power k. We just learned that. Now, what will be the expected value of the same thing? So the expected value is defined like this. You write it like e of x, where this is expected value. And what you do is you sum this, since this is a discrete distribution. When I say discrete, I mean the random variable takes on discrete points like 0, 1, 2, 3, and it does not work on intervals. It takes on certain points, right? So we're going to sum over all those points, in this case only from 0 to n, and we're going to sum probability of x equals to k multiplied by the event itself, which is k. So x is taking the value k. So we are going to sum up all the values of k into probability of x equals to k. And this is going to give you your answer. So what is the summation again? Summation can be written in simplified terms as follows: k into n choose k into p to the power n minus k into 1 minus p whole to the power k. This is your summation. And if you were to evaluate this summation, you would simply get n into p. So this is basically the expected value of a binomial distribution, and you can also find out the variance using the same techniques. The variance of a random variable x following a certain distribution is defined as expected value of x square. So basically the average of x square minus the expected value of x whole square. So this is known as the variance of x for any distribution. So even if you were to calculate this, you would get this value as n into p into 1 minus p. And this would simultaneously make the standard deviation as square root of this. So this would basically mean that sigma of x, which is the standard deviation of x, is nothing but root over np into 1 minus p. And this would complete all the theory we have related to binomial distributions. There are other terms like kurtosis and skewness and stuff like that, which you do not require in this particular examination in JE or any high school examination. But if you choose to study mathematics after this, you will certainly come across those terms. Certainly, if you are going to study, let's say, AI or machine learning or data science or maybe probability and statistics, you will be seeing a bunch of these, and this is just the tip of the iceberg. You're going to see a lot of these topics like normal distribution, tree distribution, students tree distribution it is called, and then there are so many topics, right? So probability is very vast, and this is just the beginnings of distributions in probability, and this is what you have in JEs, and ISI and CMIs won't even ask after like anything beyond this. So yeah, we can walk off with this one, and let's close this off right now. And because I only wanted to explain this, so in the next session, I would try and explain some other theories about classical probability, like Bayes theorem and stuff, and we can do some PYQs. And then probability would be done for good. And I'll be bringing other videos to my channel. But in the live stream, we would not be required to do probability anymore. Anyway, so this whole session, I have explained everything about binomial distribution and probability. If anyone's new or watching it later on, you can just go back and check from the beginning. I have included an example and made you a list of all the theories. So basically, all this is basically the theory for binomial distributions, and this would be enough to understand them on a ground level and solve problems with this. So I'll close it off for today, and in the next session, we can do some integrations and some algebraic topics and also some classical probability. Anyway, thank you.